All right, so we are going to move into section 2.3, which is the derivatives of natural logarithmic functions. So in the last video, we talked about how to take the derivative of exponential functions with base c. So we're going to continue that by moving into natural logarithmic functions. This is also the last section for chapter 2, so we'll be finishing up this chapter today as well. So just like exponential functions, when it comes to taking the derivative of a natural log function, there are two rules that you're going to have to know to complete these problems. So number one is kind of like the standard rule, like e's were. If you take the derivative of just the natural log of x, and that's the only thing there, then your answer will always be 1 divided by x. Where you've got to be careful, like in e's, is that when you take the derivative of a natural log and inside of that is something other than x, so natural log, let's say f of x, then what you have to do to find the overall derivative is you're going to write out a fraction. Whatever this inside function is, it goes on the bottom of your fraction. Then you'll take the derivative of that and put it on top. The other big difference to be careful about here is that when we took the derivatives of e's in the last video, we just kind of brought the e along. When you take the derivative of just a natural log function, there will not be any natural logs in your final answer unless there's something else added on to it. So a lot of the problems today, we're going to start with natural logs, but after we take the derivative, there won't be one when we're all said and done. So let's look at a bunch of examples here. So we're going to find the derivative of a bunch of natural log functions with different combinations. So number one is kind of like your basic rule. If y is equal to -8 times the natural log of x, if you want to find the derivative of this function, so y prime, -8 is just a constant, so you'll bring that down. And then from the rules I just went over with you, when you take the derivative of ln of x, that is just 1 over x. Multiply those together, and your final answer is -8 divided by x. And that's how you'll do just a basic natural log derivative. Obviously, be careful because things like number 2 are going to show up a lot more. What happens if inside the natural log it is something other than x? So if you want to take the derivative of the natural log of 6x, so let me remind you about that rule. When you take the derivative of the natural log of a function, you're going to write this out as a fraction. Whatever's inside the natural log goes on the bottom, and then the derivative of that goes on top. So for our problem, if you want to find the derivative of this natural log function, we'll start with a fraction. The 6x that's on the inside will go on the bottom. The derivative of that, which is 6, will go on top. Now, usually in these problems, something might simplify, so do pay attention to that. Both the top and the bottom have a 6 in common, so this 6 and this 6 cancels, which leaves a 1 on top, and actually you get the same derivative as your standard rule by coincidence here. So the derivative of the natural log of 6x is just 1 divided by x. All right, let's do a few more rules here. So number 3, if y is equal to the natural log of x to the 4th, what is the derivative of that function? So this is the same rule we just did on number 2. When you go to find y prime, since this is more than just x, we're going to start off with a fraction. This x to the 4th is going to go in the bottom, and the derivative of that is going to go on top. So the derivative of x to the 4th is 4x cubed. And then from here, you probably have to simplify something, so let's look. It looks like on the top and bottom, you have x cubed in common, so this x cubed would cancel, and 3 of the x's on the bottom would cancel to leave you with a final derivative of just 4 divided by x. So that would be the derivative of your function. Number 4 is no different. If you have h of x equals the natural log of 7x squared plus 5x plus 2, that inside is something other than x. So when you go to find the derivative of this function, You're going to start off with your fraction. This whole thing on the inside is going to go on the bottom. Then you're going to take the derivative of that and put it in the top of your fraction. So the derivative of 7x squared is 14x. The derivative of 5x is 5, and then 2 goes to 0. Now this time it's actually a little bit better. If you look at all of those terms up there, there is not anything in common that you can cancel out. So actually, this is as simple as your derivative gets. So that is the derivative to number 4. All right, so now we're going to move in some combo rules. So kind of like we did in the E section, now that we have natural log derivatives down, let's bring in possibly some product and quotient rule examples. So number 5, if y is equal to x to the 6 times the natural log of x. So what you should, once again, hopefully you're noticing this a lot more easily. You've got two functions being multiplied together. Since they're multiplied, I'm going to have to call the first one f and the second one g so that I can apply my product rule. So the product rule here, once again, is f times g prime plus g times f prime. So if I apply the product rule here, I'll take my f, which is x to the 6, times the derivative of g. The derivative of natural log of x is just going to be 1 over x. Plus your g function, which is the natural log of x, times the derivative of f, which is 6x to the 5th. Now when I put these together, over here on the left, if I do x to the 6 times 1 over x, this x will cancel. One of these x's will cancel because they're being divided, and that will give you an x to the 5th. Now, a very common mistake over here is that people try to multiply this x and this 6x to the 5th. That is not correct. Remember, this x is the inside of your natural log function, so you can't put these together. All you could do here is you could bring the 6x to the 5th to the front, and we're going to multiply this by the natural log of x. Honestly, that's probably a good enough answer right there, but just in case, you could factor this like we did in the E section. They both share an x to the 5th in common, so if you were to factor that out, it would be 1 plus 6 times the natural log of x left over, just in case the homework asks you to put it in fully factored form. All right, number 6 is actually very similar, so I'm going to try my best to keep that formula at the top because we're going to use the product rule again here. I want you to be able to find the derivative of g of x equals x squared times the natural log of 3x plus 7x cubed. So once again, you see these first two terms are being multiplied together. So that's x squared times the natural log of 3x. I'm going to let the x squared be f, and I'm going to let the natural log of 3x be g, and I'm going to do the product rule of these two functions. The 7x cubed I'll come back to in just a second. So g prime of x is going to equal your f function, which is x squared, times the derivative of the natural log of 3x. So remember, you start with a fraction. Whatever's inside the natural log goes on the bottom, and the derivative of that goes on top. So the derivative of 3x is 3. Plus your g function, which is the natural log of 3x, times the derivative of f, which is 2x. Now that finishes the product rule of the first two terms. But don't forget, you still have this 7x cubed right here. Since it's being added on to the end, you just take the derivative of that separately, which would be 21x squared. Now, to clean this up a bit, if possible, let's see what we can do here. First thing, the 3's canceled, so that's really nice. This x multiplied by the x on the bottom here multiplied by this x squared. This x cancels one of these x's to leave you with just a first power. So that just gives you an x plus, if I brought this 2x in the front, that would be 2x times the natural log of 3x. And then I'll bring down the 21x squared. And just like the one above, I'm actually okay if you get to this point right here. That's probably the form they want it in. But just in case, if you technically look at it, they all share an x in common. So we could factor an x out here and make it 1 plus 2 times the natural log of 3x plus 21x. I don't think they'll do it in that simplistic way, but just in case, I want you to be prepared. All right, so we haven't done any quotient rule yet, and we don't do a lot of quotient rule with natural logs, but I did want to show you one. So let's look at number 7 together. If y is equal to the natural log of x divided by x to the 5th, let's find the derivative of this. So since you have an x function on top and an x function on the bottom, that tells us we have to do the quotient rule. So I'm going to let the top be my f function and the bottom be my g function. The quotient rule says we can take g times f prime minus f times g prime, all divided by g squared. So let's apply that here and see what happens. Y prime is going to equal my g function, which is x to the 5th, times the derivative of f. The derivative of ln of x is just 1 over x, minus your f function, which is the natural log of x, times the derivative of g. The derivative of x to the 5th is 5x to the 4th. All of this divided by g squared. So x to the 5th all squared. If I simplify what I can, we've seen this a few times now, this x on the bottom cancels one of those x's there. So that's just going to give you x to the 4th. Minus, I'm going to bring that 5x to the 4th to the front and multiply it by the natural log of x. And then x to the 5th all squared is going to be x to the 10th. Since we've got these three terms, you will notice, and I think it's the 3rd or 4th time this semester we've seen this, if you notice, all three terms share a combination of x's together. So all three of them have at least an x to the 4th. So I can cancel this x to the 4th out. I can cancel this one as well, but since it's by itself, there's an understood 1 there. And then these 10 drop down to 6. And you are left with a final answer of 1 minus 5 times the natural log of x over x to the 6th. That's as simplified as it goes, and there's no more factoring you have to do on number 7. So that's quotient rule. Number 8 is an example of the chain rule using natural log, which really isn't too bad. Number 8 says find the derivative of g of x equals the natural log of x all raised to the 7th power. Since the entire natural log is raised to a power of 7, this technically means you have to do the chain rule. So we haven't done chain rule in this video, so let's review that. So g prime of x. Chain rule says you bring your power to the front, which is 7. You leave the inside alone, which is the natural log of x. You subtract 1 from your power, which makes this a 6th power. And then you multiply this by the derivative of the inside, which is 1 over x. At this point, the only thing you can do is multiply these together, and you would end up with the 7, and the natural log of x to the 6 would be on top, divided by the x. Now be careful, do not cancel these x's off. It looks very tempting, but since that x is inside this natural log right here, it's not eligible to be canceled off. So this is the final answer you should give. All right. Number 9 could end up being one of the harder problems you do if you're not careful. Because number 9, the way it sits, if you try to take the derivative of that, it's going to be a lot of extra work. So the reason that is, and I'm just going to talk for a minute, Since this is a fraction on the inside, if you tried to take the derivative as it sits, you would have to remember, rewrite it out, and you would put this on the bottom, which is not the bad part. The problem is that what would go up here means you have to take the derivative of this, which would be a quotient rule. That's going to be a lot of stuff floating around and really easy to mess up. So for the first time, and I think the only time probably today, I'm actually going to do a little bit of algebra, and this is why we covered section 2.1 before I start doing a derivative. If you remember, inside of a natural log, if two things are being divided, then you can split these up into subtraction. This would be the same thing as the natural log of the top, which is x squared minus 7, minus the natural log of the bottom, which is x. That's the only algebra step you need to do here, because now we know how to take the derivatives of these a lot simpler. So here we go. Y prime will now be, if you take the derivative of that first natural log, so I'm going to start in a fraction form, the x squared minus 7 will go on the bottom, and the derivative of that will go on top, which is 2x, minus the derivative of ln of x is just 1 over x. Now, the one exception, while that made the derivative a lot easier, where the challenge now is you've got to put these two things together to make them algebraically correct. So you've got to find common denominators so you can subtract these two terms. Easiest way to do that, and it's how I teach it in algebra class, whatever the other bottom of the fraction is missing, we're going to add it on. For example, the second fraction doesn't have this x squared minus 7. So I'm going to put it on the bottom of the second fraction, but that means I have to also put it on top. The first fraction is missing that x that the second one has, so I'm going to put an x on the top and the bottom. Now, if I clean this up a little bit, this does become 2x squared on the top of the first fraction times x squared minus 7, minus, multiplying by 1 doesn't do anything, so we'll leave that as x squared minus 7 over x times x squared minus 7. And what you will notice here is that we can now put these together. So if we put these together as one big fraction, because they now have common denominators, this is x times x squared minus 7, and then combine the tops. You'll have 2x. This negative has to be applied to both of these terms, so that would be minus x squared, and then plus 7. The last thing you can do here is combine your x squareds, and I'll come down here so you can see it easier. That would give me an x squared plus 7 over x times x squared minus 7. And this is the derivative of the original function. While you may be thinking that didn't seem much easier, the derivative was a lot easier there. It was just all the algebra you had to do at the end. If you had gone the other way around, you would have had a bad derivative on top of some bad algebra. So at least we made one of those two parts a little bit nicer. All right, and then number 10, to kind of see for, I think, just one time only, where you can combine e's and ln's. So what if you have to find the derivative of a function that's an e times an ln? So number 10 is, if you have e to the negative 4x times the natural log of 6x. Well, once again, this has x's in it, this has x's in it, and they're being multiplied. So we're going to have to do the product rule on this problem. So the product rule is f times g prime plus g times f prime. So if I find the derivative of this function, we would start off by saying y prime is my f function, which is e to the negative 4x times the derivative of g. So that would start off as a fraction. I would put the 6x on the bottom, and the derivative of that goes on top. Plus my g function, which is the natural log of 6x, times the derivative of e's. Remember from the last video, when you take the derivative of an e, you take the derivative of the exponent, which is -4, and bring that to the front, and then you just bring down the e. All right, not much really simplifies here. The only thing that I see is that these 6's cancel. And if you were to multiply and rearrange some terms, you would end up with e to the -4x divided by x when you put those together. And then looks like you'll end up with -4e to the -4x. I just brought that to the front, times the natural log of 6x. And as I've shown y'all a few times in these videos, that is your derivative right here. But if the homework does ask you to go one step further and factor, both of these terms do share that e in common. So you can factor the e to the -4x out, and that will leave you with a 1 over x minus 4 times the natural log of 6x. If it doesn't make you factor, you don't have to do that, but just in case, it's there for you to review in the video. All right, 2 more things to do and then we'll be done with this video. As you've seen in the last, 4 or 5 sections, we have learned a new derivative rule, so we're going to have to find the equation of a tangent line. So number 11 says, find the equation of the tangent line to the graph of y equals the natural log of x all squared at x equals 3. Now the issue on this one, unlike the ones from the last few sections, is that I didn't give you the entire point this time, all right? I just gave you the x value. So the first thing I'm going to do is I'm going to take this x equals 3, I'm going to substitute it in to solve for y. So y would equal the natural log of 3 all squared. And honestly, I know we could type this in our calculator. I'm not going to do that until the very end of this. So for now, let's just leave that y value alone. To find my slope of the tangent line, first thing I need to do is to find the derivative of this function. So that's actually going to be a chain rule problem. I would bring the 2 to the front. I would leave the natural log of x alone. I would drop the power down to the first, and then you multiply by the derivative of the inside, which is 1 over x. If I put this all together, this is 2 times the natural log of x divided by x. I just dropped the first power off because we don't need it. And then what you're going to do is you're going to take that x value, which is 3, and you're going to plug it into the derivative to find the slope. So m is going to be 2 times the natural log of 3 divided by 3. Once again, I have not gone to my calculator yet. We will in a few minutes, but for now, let's leave everything as it is. To write the equation of our tangent line, we are going to use the point slope formula again, and it's going to look a little weird with these weird numbers, but we'll get through it and I'll show you how to do it. This will end up being y minus our y value, which for right now, we're going to leave as the natural log of 3 squared. This is equal to your slope, which I'm going to leave as 2 times the natural log of 3 over 3 times x minus my x value, which is 3. When you multiply this slope through, even though it's ugly, it actually cancels something very nicely. Multiplying it by x doesn't do anything, so we'll leave that alone. But multiplying it by this 3 right here cancels that 3 and the 3 on the bottom to just give you 2 times the natural log of 3. I am now going to add this ugly natural log of 3 squared to both sides. And here's how you're going to do this on your homework. So from left to right, you're going to have y equals. Type this number next to x into your calculator and we'll get our slope. So 2 times the natural log of 3 divided by 3 gives me a slope of 0.73x. All right. Then I'm going to put these two things together right here, and that will be the number that goes on the end. So I'm going to type in -2 times the natural log of 3 plus the natural log of 3 squared. And that gives me, actually, it's going to be negative still. So that'll be minus 0.99. I highly encourage you when you get to this problem on your homework and or quiz that you don't type any of these numbers when they get this bad until the very end. If you try to round way up here, you're going to end up messing up your values in the process. And I don't want you to keep getting off by a decimal or two and keep getting the wrong answer. So wait till the very end like I did in the video to type your numbers into your calculator. And last but not least, I want to end this video by doing a word problem. We haven't done one of these. We didn't do one in the last video, so I decided to bring it back for this section. So number 12 says the demand for a new computer game can be modeled by the function p of x equals 53.5 minus 8 times the natural log of x, as long as x remains between 0 and 800. P of x is the price consumers will pay in dollars, and x is the number of games sold, and there's that tricky thing again, in thousands. Do make a note, because we'll need this for this problem, that total revenue can be found by taking x times the price function or the demand function. We will talk a lot more about this in chapter 3, but for now, I wanted to give you that formula. We'll get into the reasoning behind it later, but for now, we just need it for this problem to work. So part A says, find the revenue function. Well, since revenue is defined as x times p of x, I'm going to do that. I'm going to take x, and I'm going to multiply it by my price function or my demand function up here, which is 53.5 minus 8 times the natural log of x. And if I multiply that x through, this is 53.5x minus 8x times the natural log of x. So there's my first answer. Part B says, find the marginal revenue, which is defined as capital R prime. Well, as I mentioned here, we will cover marginals in more detail later. For now, marginals just mean take the derivative. So if I take the derivative of this red box up here, that will be the derivative of 53.5x is just 53.5 minus, and here's that issue we saw before. You have this 8x times this natural log of x, and since they're multiplied, we have to do the product rule. So this will be your f and your g. And remember, product rule is f times g prime plus g times f prime. All right, so doing my product rule for that, and remember the minus stays on the outside for right now, you will do 8x times the derivative of g, so the derivative of ln of x is 1 over x, plus g, which is the natural log of x, times the derivative of f, which is just 8. One thing does cancel. These x's cancel here. And if I distribute this negative to the two terms that are left, you will have 53.5 minus 8 minus 8 times the natural log of x. I went ahead and just flip-flop those terms and applied the negative to it. And then if you combine your two constants here, 53.5 minus 8 is 45.5 minus 8 times the natural log of x. This is the derivative of your revenue function. Finally, for part C, how many units will be sold if the price that consumers are willing to pay is $40? So this requires us to go all the way back up here, all right? We don't actually need the derivative for this because it doesn't talk anything about rates of change. Instead, this $40 is actually the p of x in the original function. And then when you're asking for how many units, you're looking for x. So in this formula at the very top of your screen right now that I'm circling in red, I'm going to let p of x be 40 and I'm going to solve for x in that problem. So this will be 40 equals 53.5 minus 8 times the natural log of x. And I'm going to scroll down so I can actually have some room to work. If I solve for x here, first thing I will do is subtract 53.5 from both sides. So 40 minus 53.5 is negative 13.5 equals negative 8 times the natural log of x. If you divide both sides by negative 8, this cancels. And once again, we're going to end up using our calculator in just a second, so I'm not going to simplify this at all. Over here on the left, I can say that the natural log of x equals this fraction. The only thing I'm going to do is cancel the negatives off and make this 13.5 divided by 8. And if you remember back to the section 2.1 video, if you want to get rid of a natural log, you have to apply the base e to it. So if I make this side a base e, I have to make the right-hand side a base e as well. And that means this fraction is actually going to be the exponent of your base e. Now on the left, the e and the ln cancel, and you will have x equals whatever this number comes out to be. So let's type that in my calculator. And I got 5.406. Now that's not your final answer. Remember the part I warned you about earlier. If I can go away, I'm going to cover the answer up for a second. X is the number of games sold in thousands. So when you find your X value here in this problem, to get the actual number of units that you will sell, you will have to multiply this by 1,000, and that will give you an answer of 5,406. Those words in the problem do make a difference. It didn't affect how we worked the problem throughout the idea, but it does affect how you have to present your answer on your homework and quiz. So that ends the video for section 2.3, which was the derivatives of natural log functions. That also ends the chapter 2. So the second chapter was very, very short. In the next video, we'll move into chapter 3, which is another longer chapter, but it is the last chapter. So next time I see you, we'll be in chapter 3.